Good morning all. Welcome to Bhaskar's classroom. In this video, we are going to discuss about the phases of compiler. You know that very well about the compiler. Compiler is a program that can be used to translate from source language into machine language. The compiler having the 6 phases. The first one is lexical analysis. The second one is syntax analysis. Third one is semantic analysis. Fourth one is intermediate code generation. And fifth one is code optimization. And sixth one is code generation. Those 6 phases can be represented diagrammatically. In this first one is lexical analyzer. That means you know that the compiler can be divided into two parts, that is called as analysis part and the synthesis part. So analysis part is also called as a front end of the compiler, and synthesis part is also called as a back end of the compiler. That means the analysis part can take the source program as an input and it can generate the 3 address code. That 3 address code can be given as an input to the synthesis part and it can generate the required target program that can be happen in the back end. And all these phases can be connected with the symbol table. Now, what is a symbol table? Symbol table is a data structure which can be used to store all the symbols which can be used in the source program. And there is an error handler which can be connected to all the phases which can detect the errors. So, this is the simple diagrammatic representation of the compiler. Now, we will discuss about each and every phase one by one. The lexical analyzer. Now, the lexical analyzer having the 3 important tasks. The first one is read the source program character by character. The second task of the lexical analyzer is break up the groups. That is called as those source program can be divided into some groups. Those are called as a lexeme. The third task of the lexical analyzer is from those lexemes it can be converted into tokens. So that is called as lexical analyzer. That means the lexical analyzer take the source program and it can be converted into a tokens. And next one is the syntax analysis. So here in the lexical analyzer, now it can take the source program as a input and it can generate the tokens as a output. And next one is syntax analysis. As we know that syntax analysis can construct a parse tree or either grammatical structure from the tokens. That means where you have to construct a parse tree. So that means while constructing the parse tree, you have to remember that all the root node must be operators and the child node must be operands. Now this parse tree can be constructed from the tokens. Okay. Now what are the tokens can be generated in the lexical analysis phase? Those tokens can be taken as an input in the syntax analysis and those tokens can be constructed as a parse tree. Now come to the third one. The third one, here also we will construct a parse tree. Parse tree. That means now is there any numeric values in the source program? Those can be converted into float of some numeric value. So that is called as the output of the semantic analysis is parse tree only or other semantic tree. That semantic tree given as input to the intermediate code generation. In this phase, we are going to generate the 3 address code. 3 address code. The 3 address code is also called as, that is called as where we have to follow the 2 important rules, minimum and maximum rule. The minimum rule means where every 3 address code can use only 2 operands with a single operator. And what is the maximum rule? Maximum rule is maximum 3 operands with 2 operators. That is called as 3 address code. And what is the 5th phase of the compiler? In this way, we have to optimize the code. Means we have to minimize the number of lines from the 3 address code which can be generated in the intermediate code generation. That means we have to minimize the number of lines from the 3 address code. And last one is code generation. In this phase where you have to generate the assembly code from the optimized 3 address code. So finally we will generate the assembly language in the code generation. Thank you.